cadastral measurements done by Graham Howe. So we were able to generate quite a lot of coordinates there to upgrade Broken Hill. And that survey was done in 3 days, with 2.5 days, sorry. Over-observed networks, looks great, but, okay, if you look here, there's nothing, oh look, I'm not knocking this survey, but the critical lines that are missing is from there to there. If you look over here, a measurement from there to there. There's no measurement between here and here. And this is where, in control, with doing control surveys, you want to avoid that. Okay, observations, terrestrial. If you're going to submit terrestrial data, total station stuff, we don't want dumps of just pointings. We want collated values, reduced means, etc. We want to know what the type of distance is, whether it's spatial, ground at a given height, or mesoidal or ellipsoidal. And for Class C, we require double occupations of all marks. GNSS log sheets, we've already covered that a little bit, but there's some information that should be on it. Computation and adjustment. We prefer that the data that we get is being put through a least squares adjustment, mainly because that means that the data is in some digital form. Right? We don't want to have to get a whole lot of data and then transfer it if it comes on printed sheets and then have to do it by hand. We just don't have the staff to do that. If it's been adjusted, at least we know there may have been some amount of validation done of that. Plus it's in a digital format and we may be able to reformat it to what we want in most cases. And some information supporting the way you've run that adjustment. Survey report. Okay, I showed you that one example there of leases. That is what our standard type of report is, and as I said, it's in the SG 12 directions area. There's another thing there. There's a submission statement and a checklist completed and signed. That just means that you've actually gone through it and checked off. You've supplied what we required. If we look here, this is the sort of thing, this is from Bathurst Council. 2 marks were placed. Nice sketch there, there's nothing wrong with that sketch. Another sketch there. I've got some angles and distances on a piece of paper that's been scanned. There's something at level run, right? We got this. I don't know, I'm assuming it's some sort of GPS, and then I've got a list of coordinates on a sheet of paper. Now, okay, I can sit down, I could probably spend some time with that, but you know, we really can't do anything with that. Now, that's 2 marks. We'd like to be able to put them in, but it wasn't done by a surveyor or under a surveyor's supervision. That was submitted by the engineer of the Bathurst Council. Achieving the desired class, use the appropriate observation techniques, suitable equipment, correct reduction. It's all there, and you've got to pass that test. Now, to do that, you've basically got to know how good your observations are, run your adjustment. You should get all your standardised residuals within a bell curve. Now, I know this might sound a little bit technical, but you want a variance factor near unity, which confirms that, okay, what I estimated I put in is actually true. So I can then I can accept that my estimate of my error ellipses are true. This table's in SG 12. Now, just to explain that table, is to give you an idea of relationship between the errors associated with a point and the distance to the next point. Okay, so let's look at that highlighted one there, that C. Okay, let's look at, it says 15 millimetres there for the point ellipse. So let's say we've got a 15 millimetre error associated with a point. 600 metres away, there's another point with a 15 millimetre error. The relative error between those 2 points is 21 millimetres. Okay, you test that over 600 metres, and the best you're going to get is Class C, right? So that means if you go to 400 metres and you've got those errors, you're going to get Class D. And the thing is now, LPI, a lot of its work is in this sub 1 kilometre, basically under the 1 kilometre, under the 1 to 2 kilometre area. So we're working down at this lower level. Now, whether or not it's still appropriate to use this technique and that formula is maybe subject to debate and may change, but that's what the standards are based on now. Okay, so you can see when you apply point positioning to that top line, if we look at, if cause is 20 millimetres when you do a position with cause, and you do 2 points 600 metres apart, you'll get Class D. Right now, the values there are slightly different to Doug's because Doug took the manufacturer's specification. In this case, we start to add on external errors such as plumbing over the mark and other factors that you add on for external errors. This is how we get an error ellipse. We're at station 1. We have an error in our observation in angle, and we have an error in our distance, and it produces an error ellipse at the other end. That's just that's the classic method of generating an error ellipse. Then there's relative observation networks. The one on the left there is simple. It closes, provides feedback. Figure 3 there on the other side, 2 GPS receivers. Let's put a base station here. Use the second one, come down here, down all these marks, get all the radiations, move the base station over to this point, do the same thing again. Double occupations, Class C, fantastic. Look at all the error ellipses of these. Okay, for the lines observed, fine, pass the test. But if I test the error ellipse between that point and that point, it fails. Right? Looks very good until you look at lines not observed. Okay, this is graphic characteristics of measurement. Now, this is in terms of relative error ellipses, as I was talking about. You can see there's a number of lines there. Now, that blue line there, Class C there. What you want to do is look at the intersection points. I've put 2 cause net positioning values there. One at the bottom is if cause delivers 10 millimetre positioning, I can go down to Class C, down to, where is it? About 250 metres. But at 20 millimetres, I can only go down to 700 metres. Now, LPI at the moment, maybe 20 millimetres is probably a safe thing for us to publish. But I think we're somewhere halfway between that value in most good cases. So we're still at around the 500 metre cut-off using things like network RTK. So you can't get your points any closer together if you want to achieve Class C. You can see there's a couple other ones. There's EDM, 1 millimetre plus 1.5 parts per million. You can't beat that. That's the best. Static GPS, and I've got 2D there. Now, static GPS there's 2 components to get a point. There's an easting and a northing. Now, generally, when you take the combined value of the vector, you end up with something that's close to 10 millimetres plus a part per million in terms of including external errors. Right, so you can see now where that cuts, where that one will cut across. Okay. Oh, and that was that little graphic I had up there before was just, that's how I calculated the relative error ellipse. Okay, not restricted. So we're looking here at things like in RTK, we deliver position. At challenges class, which is based on relative error ellipses. So we've got to come up with a technique of calculating relative error ellipses. That's a typical position observation network. There's a few things here you've got to be aware of. Points are uncorrelated. Every error ellipse is the same size. Every relative error ellipse is the same size, provided every point is observed the same number of times. We recommended a minimum of double occupations for Class C. Adjusting to a datum, we require that you connect. If you're going to do something to submit to SCIMS, you must connect to existing SCIMS marks. Otherwise, we can't propagate the SCIMS coordinates without some connection to existing SCIMS. Okay, I hope this presentation helps explain why some things are the way they are. Control surveys are a specialised process. I've got there the position observations are with us. Are they really control surveys? Because you don't have any relationships or correlations between points, that's, I've said there's something missing. Important line there is it's not LPI's task to determine whether or not someone has fulfilled their contractual obligations. Right? If a client lets a contractor do some SCIMS work, it's not up to us to determine whether or not you've determined that. That's the client's problem. Please contact us if you're going to do some sort of control survey work. It'll save you a lot of heartache, and it may reduce the amount of work that you actually have to do. And that tripod on slide 16 was plumbed over the mark. It was an optical illusion. Okay. Thank you very much.